As we go into our last chapter in our Math 1108 course, it is Chapter 10. We're going to take a little look at statistics. And we're going to go through the first two topics, frequency distribution and measures of center. Now, in the study of statistics, this is something that actually goes through many different courses, in social studies, in mathematics, of course. But we wonder about collection of data, and we like to do statistical models. And it's used in manufacturing, in government, agriculture, medicine, social sciences, and of course in marketing. We're always interested in what trends clients, customers, what they're interested in purchasing. And of course, we know that if you use a computer and you go to various sites, there are softwares that the company has through cookies that'll record your activities. So if you look at baby products somewhere, next thing you know, you start seeing ads on your own computer about baby things. And if you are looking at shoes, next thing you know, you start seeing some ads about shoes. So in topic 1 of chapter 10, we're going to deal with frequency distributions. Now here we're looking at a specific population. And within this population, variables. I see I'm getting some pop-up things here right now. Well, you recall when we did probability, we talked about sample space. Well, that's what we're going to do. Now, often you can't find an opinion or a response from everyone within a population. So you're going to deal with some sort of subset, which will be your sample. This will be the data. And in your textbook, they talk about some of the difficulties in getting a proper sample that represents the population of interest. They go on to talk about, well, who do you get when you sample something? If you are calling people on a phone, then in order to get their opinion, they have to have a phone. And then they have to want to answer your questions. I could recall when we studied sampling in science that this group of scientists were trying to sample a mouse population. And what they were finding, they kept getting the same mice all the time because they were offering a piece of cheese or something, and these mice got trained. Hey, let's go get the cheese. So you got to be careful about that and what you pick. I could recall one when they were studying hormones and in a population of rabbits, and they were working with young rabbits because they were easier to handle, and of course the hormones in a young rabbit are different from the hormones in an adult rabbit. So there are all these different qualifiers and variables that you have to control for. Today, I don't know whether you have this, but we get calls every once in a while asking would we participate in a phone survey. And I generally do because I'm a little bit of a scientist and want to help promote this. But one of the big inaccurate polls that went on sometime in the past, in fact my birth year, 1936, was when they had called people and they said for sure that Alfred Landon would be the president of that election. But in fact, Franklin Delano Roosevelt won in a landslide. And the reason for that is that, they used the telephone. Well, rich people had telephones, and they're the ones that voted for Landon. But there were many people that didn't have phones that were voters, and they voted for Roosevelt. Okay, and again, as you collect your data, you want to organize it and study it and do some what we call statistical analysis. And that's what we're going to look at next. So in example 1, back in 2011-2012, they looked at the annual tuition in thousands of dollars of 40 community colleges. And this is what they got, rounding it off just to 2 places. And these are the data. So what they wanted you to do is to identify from this data what are your populations and variables, group the data into intervals, and then find the frequency of each interval. Now, generally what you would do if you had this random data here is organize it. So what I did is I took a piece of paper, and I, over on the right side of the paper, well actually the left side, I made a little chart here, where I did something like this. And then I took my data and I started to write the data in. Let's say this will be the 1s in here, this will be the 2s, the 3s, the 4 and the 5s. And then I put them in order. Well, here's a 3.8. So I'm going to put the 3.8 over here somewhere. And the 1.1 I'm going to put right over there, because I didn't have any 1.0s. And I started to organize my data. And that's what they're asking you to do. So what are your categories? Well, as you look at your overall data, you might say, well, I'm going to put them like this, in 1, 2, 3, 4, and 5. Or as you see down below, they're going to put them into smaller categories. They're going to have it as, and we'll see it in just a few moments, and they do the same thing. So this 1.1 would go right there as actually just a tick. How many do we have there? And then eventually say, how many do we have altogether? We could see it a little bit, that you would get 4 ticks there. And then that would be 4 as a total. And then here there wouldn't be any, but in this next one you'll see there's going to be 1, 2, 3, 4, 5, 6 category, and they just do a summation. So there's a number of ways you're going to organize your data, but here is a suggested one. And it would look like this. So this is your, over here, your frequency intervals. And as teachers, we often do this in organizing data from tests and things particularly. We like to see what the class is doing and where weak areas might be, strong areas. And we study statistics all the time. And here, of course, as you see, your largest area. And now we can start to summarize our data. Well, what else can we do to it? Well, we have our data then, a grouped frequency distribution. And now we can picture what our data looks like. And two of the common ways of doing things would be to do what we call a histogram. Now, what is a histogram? Well, you have your vertical line here, which is your frequency. In a sense, you recall this was your y-axis. And then down along the bottom, your tuition areas in thousands of dollars. So you recall from that first one that there were 4 in that category. So you would put like a little bar right there. Now in the second area there were none. And then in the third there were 6, and then there were 3, and then there were, how many there were there? 7 or so. And then this one was 11. This was a 3. This was a 2. And then this was a 4. Now, that would be your histogram as you filled in below those categories. And we would think of this as the old bar graph. And then if you were to connect the points, as we see here, with a line going to the center of each of these, that would be your histogram, or a line graph. So the combination then, as we see it, would be a histogram with the bar, and then a frequency polygon as the line. So if they ask you to do something like this, this is what they're referring to. And for these, we use the midpoints of our bars, and this is a reflection of the data we had before. And here for another quick shot of it, and I will hold up what I did so you can see how I organized it. And example 2 is to do the frequency of what we did in example 1, which was shown on the previous page there. Right there. Now again, graphing calculators have the ability to actually produce histograms, but we're not going to be doing that. Now the next thing we're going to do in example 3 is what is called a stem and leaf plot. Now, being a former biology teacher, I said, oh, this is going to be right up my line, you know. But no, we're not dealing with leaves and stems of plants. It's just a way to organize data. So once again, it's going to look something like almost a T-chart that we did a long time ago, where we're going to put in this column the stem, which is some item of this. It's going to be items that begin with a 1. And there were 2 categories for 1, and then 2 categories for 2, and then over in this part, we call it the leaves, and that was the second part of the number. And you might recall we had initially there we had 1.1, we had 4 of them, 1.1, 1.1, 1.1. Well, they're calling the 1 in each of these the stem. And then what comes after it, after the decimal point, this part, and I'll change color here to green, a leaf. And there are 4 ones. So that's where you get this from your stem and leaf plot. So as we go to the second part of our plot down here, 1, there weren't any, so those are blank. But then as we go to the 2's, you'll see that there were 2.0, 2.0, then 2.1, 2.3, 2.3, 2.4. That is, in essence, what a stem and leaf plot looks like, based on the diagram and the plotting, the distribution we did before, or saw before. So in this category of 3,000, there was 3,500, 500, 500, 3,600, 3,900. And here they're just giving you a key as to how the units are shown. This is the stem, then this vertical line, then your leaves, in this case a 3, indicating $5,300. Okay, so again, a way to display your information, the data you collected. In example 4, deals with health. Lists the original data for the following stem and leaf plot of resting pulses taken on the first day of class for 36 students. So this is your stem and leaves plot. So here we had a student with the resting pulse of 48. Then a student of 52, 57, 58. Then 60, 63, so on and so forth. And again, giving you a key of what the units look like. This is the stem of 90, and this was the second item, 9D, 9 and 0, 90 beats per minute. And then this, of course, is your answer written out. All right, this next part is mostly vocabulary and recognizing things. So, for instance, once you do get a histogram, and what is its overall shape? Well, if you see something like this, here, this is what we call uniform shape, where the columns more or less are about the same. So for this type of histogram, where the columns are about the same size, we call that uniform shape. Now, one of the most common ones that we see is where it looks like this. It's slow, starts up, reaches a pinnacle, and then starts down. In fact, you'll notice it looks like a bell. This is often referred to as the bell-shaped histogram or a normal-shaped histogram. Now, sometimes as we look at it, we'll see the data is skewed. That is, it sort of thins out on one side or the other. So in a moment we'll see left skewed and then right skewed. So hopefully in your notes you're making some pictures or taking notes of this. So in this one now you see it's skewed to the left. and this is skewed to the right. So as we look at example 5, we're asked to characterize the shape of this distribution. Well, it seems to have a bell shape, more or less, so this would be normal. Again, hopefully something a little easy for you. And then in part B, as you see it, it's skewed to the right. Let's get that right here. Okay, now it's almost normal shape, but again, because of this extended portion here, they say it's skewed to the right. Then you'll have some exercises and in your booklet and in your study plan. And good luck.